Hello, in this video we'll be discussing covalent bonds. So let's not waste any of your time, let's get right to it. Now when we're talking covalent bonds, we're talking bonds that occur where the atoms share the electrons. You can see in our diagram that we've got a hydrogen, we've got two hydrogen atoms, we've got an oxygen atom. The hydrogens have one valence electron on their valence shell. The oxygen has 6 valence electrons on its valence shell. And so when those two come together, H2O, 2 hydrogens, that's water, hopefully you know that they are looking to fill their outer shells. They're looking to meet the octet rule. But covalent bonds are tricky. If you've been in a chemistry class and you understand what's about to happen. But when it comes to the octet rule, you got to remember the electrons are counted for both. So if you look at the red electrons, which are the oxygen electrons, and the gray electrons, which are the hydrogen electrons. If you look at the hydrogen atom, it has its own and it has one red. So 2, it has one ring, so it's a full outer shell. Same with the other hydrogen. If we look at the oxygen atom, it has the 6 of its own, and then we count each of the 2 hydrogen atoms. 6 plus 2 gets us to 8, which meets the octet rule. And that's how you would count that. Again, a chemistry class, you'd be doing that a lot of times to get a lot of reps in. We are not so focused on that, just an understanding of it and a recognition of it with some slight practice, but it's not a hard and fast thing that we are focused on. But we do want to identify what a covalent bond looks like and how the electrons are shared and counted. Okay, when it comes to covalent bonds, because of the meeting the octet rule, there are 3 types. A single covalent bond, a double covalent bond, a triple covalent bond, and you can see the message there that be sure you take the time to draw these diagrams and understand what this looks like. But if you are a element that needs 2 valence electrons to meet the octet rule, like an oxygen, you could bond with individual hydrogens, okay, or you could bond with one element that has 2 that you can share. So an oxygen atom has 6, it needs 8. Another oxygen atom has 6 and needs 8, so it can share the 2, and then each of them would have 8. And we previously talked about how to count those, and so you can physically count those, mentally count those to understand that. But most covalent bonds are bonds between 2 of the same atoms, and they form gases when that happens. Oxygen gas, nitrogen gas, chlorine gas, those phosphorus gas, that kind of stuff. And so most covalent bonds are in that situation, and it's easy fix and easy configuration to figure out when they do bond to themselves, because they need the same amount and then they can share those same amounts. But single, double, triple, make sure that you again add those to your notes, draw the diagrams, and have that information. Now this topic is one of our more strenuous topics, and we'll do some things in class to help with this. But the idea of a covalent polar bond. The word polar refers to, in a molecule, there are 2 ends. Okay, just like 2 ends of a magnet, 2 ends of a magnetic field, 2 ends of the globe. A bond has 2 ends. Now, the atoms in a covalent bond share the electrons because they're generally the same strength level. They're not wanting to share the electrons, they are pulling on it. But they're typically the same strength, just like if you had a tug of war between two teams and the two teams are the same strength. Typically, you're just going to have a standoff. The red ribbon in the middle will move a little bit, maybe in either direction, but not enough to win the event. This is similar to a polar covalent bond. It's the idea is the electrons of the hydrogen are pulled a little bit closer, in this case by the chlorine. It also happens in water, which we'll talk a bunch about because it's a huge deal. And when that electron is pulled a little bit closer to one of the atoms, it makes more electrons, more negative electrons on one end than on the other end, and therefore you have a positive end and a negative end. The end that the electrons are being pulled to, that would be the negative end, and the end that they're being pulled away from, that would be the positive end, and that makes that polar. But that's a huge deal when we're talking properties of water, which we will get into in a later video. Well, that's our show for this video. In our next video, we'll be discussing ionic bonds. We'll see you then.